Okay, so we're recording. Cool. Alright, hi everybody. My name is Bernice, and this is a video presentation of something that I've been development. So, this is my game called Dagat, and it's been in development for some time now. And here's a demo about how it works. Here it is. This is Dagat. And it's basically like an endless runner, except you're a fish, so I guess it should be called an endless swimmer. Endless swimmer game. So yeah, and everything kills you here. So basically, all these things that you see on screen, the sharks, the jellyfish, and the plastic bags are all things that can kill you. In this case, we were eaten by a great white shark. If you touch the jellyfish, it will say that you were stung by a leopard jellyfish. And if you, I'm gonna see, how else can you die here? Yep. Oh no, I'm gonna get stuck in the plastic bag. Yes, if you go inside the plastic bag, you get suffocated by a plastic bag. So this is actually what goes on behind the scenes. The background doesn't actually infinitely repeat itself or grow forever. It's actually 3 separate game objects that just object pool and repeat themselves. In case you're not familiar with the term object pooling, in game development, object pooling just means that instead of instantiating and destroying a new game object every time it needs to appear on screen, which both of those processes are very CPU and resource intensive, you just recycle game objects and move them to where they need to be seen, or make their renderers visible or invisible. So these are 2D objects, so in this case the renderers are sprite renderers instead of mesh renderers, which are used for 3D objects. And the secret sauce behind making these two things, the background repeat forever, is actually these 2 pieces of code right here. I have a background manager script and the backgrounds. What the background manager does is it gets an array of game objects, and in this case the game objects are the background tiles. The background tiles are simply these ones. Right now they're the C columns. Yes, this is the part that's calling the script. The background container is basically like the game manager for the background stuffs. We have an array and they're full of things with C columns. I just chose 3 because I think that this is big enough for various camera sizes and screen sizes, so that there won't be a strange gap where like, whoa, where did the background go? And we need to get the offset of how far the backgrounds go. And how I got the offset is basically I get the width of each of the tiles, and I multiply it by 2 because we want the tiles that are not seen by the camera frustum to go to multiplied by 2 positions of where it would be. So that's basically like predicting where the next one would go. And this function here, recycle backgrounds, is the one that recycles the backgrounds. This piece of code gets called by backgrounds, and each of the tiles or 2D sprites that are actually the backgrounds, in this case they're called C columns, have this in their components. They call the background manager, and on became invisible is basically a function that's provided by Unity, which is the game engine that I'm using. And every time the sprite renderer of of the tile, the quote-unquote tile or game object that I'm trying to track goes outside the frustum of the camera. Basically, they're not being rendered anymore. They call the recycle backgrounds function, and it goes to this .game object, which is basically the object that has the script. And that's the important part. The important part here is that the actual things that I want to quote-unquote recycle through object pooling should have a sprite renderer. Without this part, the background tiles are not going to repeat. I did the same thing also with the hazards, as I call them. Like, I was gonna say other fish, but then I realized, oh wait, there's a plastic bag there, and that's definitely not a fish. Although sea turtles sometimes think they're fish or like jellyfish and try to eat them, but that's besides the point. The point is that the hazards are also object pooled, so the game doesn't actually like create tons and tons of them, because that's really bad for processing power. It's gonna slow down the entire thing and make the game, kind of unplayable and laggy and not fun at all. So let's see if the positions of the hazards are also randomly generated, and it's controlled by this part here, the game manager. Oh wait, no, that's the game manager is the part that controls, or the hazards container. I shouldn't call it container, I should just call it controller. The hazards controller controls where the fish spawn, and this does the same thing too, which is basically we get an array of game objects. In this one, I just call them hazard prefabs because they're grabbing from the prefabs that you see here. The leopard jellyfish, the plastic bag, and the shark. The seagull's not gonna come into play yet because I haven't drawn and animated it yet, so right now it's just a little dot. Further along development, I'm going to draw the seagull in the same style and make some animation so that it can be seen eating the fish. So we have an array of game objects for the hazards, and I want the positions to be like pseudo random each time the game starts, so that the game won't get boring and predictable. And that's why I have variables here for the minimum starting distance and the maximum starting distance for X and Y. And I have serialized field here for the player character because we want to use the player character as the point of reference, and we have some offsets here. And we have a variable, a vector2 for screen boundaries. This part actually explains what the screen boundary is. Unity has an object called camera, and what this class does is it has things like frustrums and screen boundaries and other tools like that. So it's the main camera in the game that we view that we view things with, and there's a function here called screen to world point. So in this case, it takes in a vector3, and basically what the screen to world point does is it takes the position of the camera and translates it to a point in the quote-unquote world of the game. And the screen position of the camera goes in through here. Like, we get the width of the screen, the height of the screen, and since screen to world point is a vector3, there's no like vector2. We need the z position, so I just assign this position as the Z position of the screen. And what it does is it grabs information from the game object array here of the hazards. So for each hazard, it assigns a random starting value on the X position and the Y position and instantiates it. I did mention object pooling, but this is the beginning when nothing is instantiated on the screen yet. So here, like each hazard, and quaternion is basically just the rotation. So we have offsets, which basically tell you like how far in the X and Y values or positions they are. And the reason why we have this part of the code here, this was added in much later because I had to solve a problem of the hazards not spawning properly if I move the fish horizontally or vertically. So this adds a script called became invisible, which is also one of the tools that I use for object pooling. Anyway, since we mentioned talking about the random positions of the hazards, I think I'm just going to show you how that works in action. Alright, maybe I'll just show you the prefabs also because this is kind of interesting. Open prefab. So since it's a 2D game, all the renders here are just sprite renders, and it basically takes an image that I've converted here. This is it. This is an image that I made. I drew this and put little eyes on it to make it more like animated, quote unquote. So the hazards all have sprite renders which have their images, and they all have colliders, and over here is represented by this green capsule that you see here. I chose a capsule because that's generally the shape of what this graphic looks like, and each of the hazards have their own form of movement. When I press play, you can see that the jellyfish animation is spinning along the x-axis, and that's all controlled here. All of them are rigid body, and the rigid body is just important for movement later. And there's one script here which I added much later in development because this was solving a problem of not being able to classify what the animals are or the hazards are that killed you. It's the same thing here for the shark. Let's open the prefab. For the shark, since the shape is like more uneven, instead of using a circle collider that you saw me use in the jellyfish, I used an edge collider 2D, and basically this allows us to more or less conform the shape of the collider to the shape of the graphic that we have here. But everything else is the same. We have a script for the movement, we have a sprite renderer, and we have the rigid body, and another script here that tells the information about what objects our main character fish has collided with. So it's the same thing here for a plastic bag. The plastic bag was created more or less the same way as the shark, where I'm not using a circle collider, but I'm actually using an edge collider. Anyway, here's a demonstration of how this kind of works. You hit play because it's random. It's going to be different each time. Play. I'm stopping it so you can see that they're different again when I hit play again. Play. Yeah, they're all in different positions. Play. So yeah, they're all in different positions again. Anyway, one big obstacle that I have encountered while creating this game was originally because when I was able to create the logic for the hazards to appear, but as you can see here, if you continuously just go up or go down, the hazards only kind of spawn randomly in front. I had to figure out how to make the hazards spawn on the top so that it won't be too easy, or on the bottom so it won't be too easy. Because as it happens now, you basically can go as far up, keep pressing up, basically press up to it until you go to the top and you get eaten by a seagull. Or you can keep going down, you're never going to hit any of the hazards until you reach the bottom and die from deep sea pressure. And how I solved that was I basically made a separate script that handles the random positions of the hazards if you make the fish go up or if you make the fish go down. And that script is just really similar to the original hazards manager, except that the values are futzed around a little to basically suit the need of going up or going down. So you can see that they're a bit different here. And also the reason why, if you can notice here, I put a shark in the main hazard spawner, but I don't have them here in the vertical ones, is because after a bit of playtesting, I basically realized that there are too many sharks and it just basically made it really hard to move and to play. So I just did not render a shark in the vertical versions of this. But basically they're all the same. They just spawn the hazards in different places. But this one just handles going up and going down. So I'm going to show you what happens if I enable this game object again. This vertical's up. If I press play, and I'm gonna go up. Oh, there's stuff up there, so I can't really win just by going up anymore. Oh. Yeah, there's always gonna be stuff in front of me, but nothing going down because I disabled the script for that. But going up, oh, there's plastic bags and other things. Oh, I can't go up to win. Or I mean I can, but it's like much harder right now. Alright. Oh, I died again. Oh yeah, so that's the part that I was kind of talking about. And now like I'm going to enable the script for spawning the fish going down. So here it goes. No, okay, now if I go down, there's a spawner for handling the logic of making new stuff appear here. So if I press down, oh, I cannot win because I'm gonna hit the plastic bag and I will die. So earlier I mentioned that I needed something that will capture which game objects and hazards my main character fish has collided with. So I'm going to show this here. killed because suffocated by a plastic bag. That was that extra name script that you have seen in all of the hazards. They all have something there that describes what the creatures are called or that you hit them. Let's see what happens if you hit a jellyfish. Now it says stung by a leopard jellyfish. Okay, so the main problem that I am trying to work on right now is okay, so the randomization is working just fine, but as you can see, sometimes there's a weird popping in effect that I'm trying to solve because that just really looks unprofessional. And also, as you can see, let me pause it. Oh, I'm just being lucky that I didn't hit anything. So okay, the game is paused now, but you can see that the plastic bag and the jellyfish just basically spawn on top of each other. So sometimes you can't see what's there, or there will be like weird edge cases where where a whole bunch of them just spawn right beside each other, and it basically creates a wall, and it becomes really unfair for the player. So I'm trying to show a good example of that. That didn't work. Okay, restart and show it again. So it doesn't happen all the time, so it's not really that bad, but when it's bad, it gets really bad. Yeah, as you can see, the plastic bag and the jellyfish spawn right next to each other, so sometimes you can't even see stuff because they might be hidden by the bigger game objects. And I'm going to show an example where there's no clear winnable path. Example where there's no clear winnable path. Okay, I'm going up and everything seems okay. Here, so this could be an example of no clear winnable path. There's no minimum distance between the jellyfishes, so there's really no space for your main character fish to pass. And that's a problem I'm trying to solve by trying to get the extent of the sprite renderers of the graphics, so that we can, and also their colliders, so that we can find a way to calculate a minimum distance. And I think later that can lead to interesting gameplay challenges, which is in the beginning when the game is quote-unquote easier, then I can make the then I can make the spaces wider, and as the player goes further and further along the game, the spaces between the hazards gets narrower and narrower, and thus gets more and more challenging. Anyway, I think I might have forgotten to show you the game logic that I made for the main character. This is basically the player, and the main camera is a child object of the player, and that's the reason why it follows the player character around. Player character also has a sprite renderer and the movement script, and a capsule collider and a rigid body. The rigid body is basically what allows it to have movement, kind of like the same way the shark in this game does. This is the player movement script and how it looks like. So this is the part that captures the collider info of the game object or hazards that kill it, and that's what inputs in the screen in the game over message. But the movement logic is basically the same. We will get, oh yeah, actually this is the part that provides the logic for going to the bottom and it flashes red to warn you that you're getting too close to the deep sea where the pressure will just crush and kill you. If the position is lower than this number here, and how I got this number is basically I know what the size of the sea tile, the background sea tile is, and the middle is basically 0 and the bottom is negative 54 because the size of this thing is 108 pixels. So once we reach the bottom, we're going to start the animation for the flashing red. But we also have like some game logic here because we want to turn off the flashing that happens once you go above a certain threshold, because I found out earlier that if you turn it on, you need to turn it off manually. This part is the one that brings the logic for when the fish dies. And this is if you go too high, basically like to the top of the sea, the seagull will come up and eat you. This is the part that controls the logic if you want to use the keyboard to control the movements. Basically, like you can use WASD or the arrows. And this input get axis is something that's just provided by Unity. I think I will show this to you right now. It's in project settings, input. Here we go, input get axis, vertical. This is for going down and for going up. So the main controls here are using the down arrow and the up arrow, and the alternate ones are the S and W. And I just use W and S just because those are basically like gameplay conventions for a lot of like basically games, like if you play like Team Fortress or Half-Life or Portal or any PC game, basically WASD is the movement keys, and that's how that's there. But I also have controller support here, and that's the reason why I have this section of the code. So if you use the left joystick, it moves the fish up and down. Oh yeah, it also supports using the arrow keys on the face buttons of the controller, and this part takes care of it too. This is the part that checks if it has collided with any of the hazards. And so you remember how previously I said that they all have colliders. This is the collider of the fish character that we have right now. And as you can see, it's a capsule collider. So there's actually a bit of leeway. So like if you touch some parts, you're not basically gonna die right away. Oh, this is the logic for when the seagull kills you. And this is the logic. Basically, you lose control of your player, and I haven't programmed the animation yet, but it will tell you your cause of death is you were eaten by a seagull. This is the deep sea pressure one, and this is the function that's being called up here, where it says if you go below this, this y, this height, this y value, then it calls this function. And here it is. This part here, the get distance function, basically controls, you cannot really see it, but if I run the game, the distance appears up here and tells you how far you've gone as your main character just swims. So let's play this again. You can see what I mean. Yeah, see, it's increasing. Oh no. Oh, yeah, that was an example of what I was trying to show you a while ago, where there's just no clear path because there's not enough space between the hazard game objects. Okay, yeah, see, the timer and the distance is increasing the farther you go, as long as you don't die. And let's pause now. There it is. Now you can see we've gone the distance of 56.78 units, and this is just 11 seconds. Let's unpause again. Oh, I got killed again. Okay. This get distance string just basically converting this float into a string so that it can be read by the UI. And this is the function for disable control. It just means that we are disabling this player movement script and not allowing it to function. That's how we disable control of the player of your main character. So anyway, what other question did I not answer for here? The question that I did not answer here is, what unique personal contributions have you made to this? Well, let's see now. The unique personal contributions that I made to this is, let's go to the credits. Everything. Okay, I'm just kidding. So basically, for this game, since I'm a solo game dev, I've done the game conceptualizing, I did the art, I did the UX and the UI, and since it's a prototype, like, you know, this is still in development and I might change the font and all those things first. I programmed the game logic and I did a lot of the testing. So the only thing that I probably cannot do by myself is music. And I can learn how to make music, but then there's this thing called opportunity cost, and I think that I might as well I could have been using that time to debug the game and make things better, and I can just get someone else to help me to add the music and things like that. So yeah. Director, programmer, art director, artist. That's basically all of it. Yes, so that's one of the reasons why you don't really hear anything, even though typically you can hear things like if you press a button, the sound comes up to make you to help you confirm that yes, you have pressed that button. I'm probably gonna add all of those towards the end once I finalize like the final look and feel that I want that this game to have. But anyway, thank you so much for watching this video, and I hope that you enjoyed it. And I guess go look at my Twitter and my LinkedIn for announcements of when I'm going to release this game. Thank you. Have a good day. Take care and live long and prosper. Bye bye. So that was my pitch video about a project that I have worked on by myself. I found a lot of things challenging because most of the uh, most of the things that or the examples of existing games that I've seen out there have Endless Runner where your vertical and horizontal is not as like you only press one button. Like for example, one really famous Endless Runner is called Cannonball, and in that game you only press one button and you just jump, and you just have to like uh, skip over holes and things like that. So I think that the randomization was one of the things that was kind of challenging, just because I don't want all of the hazards to just basically like create a wall where it's basically gonna be impassable, and because I think that's not gonna be fun. But I really find it rewarding when I figure out how to do something, and it's rewarding not only because like, oh cool, I can use this for like future game dev work or future programming work, but because whenever I show my games in indie game dev expos or conventions and things like that, and lots of people play the games and they say that they find it a lot of fun. So I think that being able to make other people happy with stuff that I make is a really rewarding experience for me. Anyway, yes. Thank you so much for your consideration, and I hope that the video was able to show you something about me. Um, Also, I apologize for the way my voice sounds because I have a cold this week, and yeah, I need to recover from this cold. Okay, thank you for your time. Take care. Bye.